This is the Imulite 1000. It's a chemiluminescence analyzer that we're able to measure multiple different hormone levels in and compare it to standard controls, which are generally based on human controls values, but we've extrapolated into using it for animal use too. To run this machine, we have to calibrate on a regular basis, definitely before each run, so that we can see that the standards are actually functioning well, so we know our values are going to be corrected. The first thing though is that the computer has to boot up. It has its own internal computer, and this will allow it to upload the data that's stored in the data bank so that it'll actually function. It will then ask me to go through a series of tests to make sure that there are fluid in the lines and everything is going to be ready to go so that it can receive the sample correctly. The process works whereby once we've added in our serum, which is told to us based on a manual for each hormone value, here showing cortisol, exactly how much serum is required at the minimal amount to run one test sample. It's going to grab a serum sample, and then it's going to place it into a tube along with the specific components for cortisol, so that when it binds the cortisol within that serum sample to a coated bead within the test tube, it can then later on flush away anything else that is not cortisol based, and we'll be able to get an actual measurement of cortisol only. What we have to set up in the meantime is we have a serum sample. This is a hemolyzed sample. Generally we like to try to keep them less hemolyzed, which means less red, more clear or yellow, depending on the species. And then we'll be able to measure out the exact microliter amount into a tube. Each tube has got a characterized label to it, this one being tube number 1. Once we have that in there, we program into the machine this animal's name, and that way we're able to track it, or the computer will be able to track it after we've entered more than one sample at a time. The program has now been uploaded into the Imulite 1000, so it's running through its own character computerized modes to make sure that everything's moving appropriately, and then it's going to ask me to make sure that certain things have no air in the lines, because air can throw off any sample's value at the far end. So the first thing it's asking me to do is remove all tubes from the chain, and then press go, because it just makes sure that things are not going to get blocked and jam the machine. Once it's done that, it's asking me to make sure that the water is in the lines appropriately, as well as a wash solution, because that way it can wash between each sample that has been entered, so there's no carryover from one sample to the next. To do this, it waits for me, and I'm able to prime the system after I hit go. And I can ensure that there's no water in the line. I've already done this just before we started, so I'm just making sure again there's no air in there. You can hear it forcing by pressure, forcing the fluids through the system and draining into a collection vessel, which stores the waste for disposal later. Each kit comes with a number of specific reagents. Those reagents have been preloaded onto this carousel, and the machine will scan these individual barcodes and put them into the so that it knows exactly where in the carousel that reagent is. So if it's asked to do a specific run on, in this case there's a progesterone example, but we'll be doing cortisol, it will actually know exactly where to pull the cortisol reagent from. Everything is primed now, so it's asking me to keep moving, so I'm pushing go again. Imulite primed itself one more time to make sure that you didn't lie to it. And then after that, it'll ask me to proceed. And now it's asking me to actually load my reagents, which we've done, and the sample, which I now have to pipette. For cortisol, it is asking that we have at least 10 microliters of serum. Because there is a very precise level of which this probe has to descend into, it has to be more than 10 microliters. It needs at least 10 microliters for a sample to run, but you have to load 150 microliters of serum so that it will not damage the probe. It will have enough volume to go below, pull up its 10 microliters, and pull out without actually damaging the probe. The probe is sensitive to the surface tension of the fluid so that when it touches it, it knows, okay, just go a little bit beyond this and take my sample. If the sample were too low, the probe could actually crash into the sample cup, and then it would get off kilter and out of alignment, and we'd have a problem. I'm now going to remove 160 microliters of this serum from this tube so that it is now in the pipette tip, and then place it into my vessel, which is a sample collection system. It's very important for this specific machine never to have a bubble at the top of your sample. So I now have a little bubble because I ejected it completely. I removed the bubble by sucking it back out, and it's now bubble free. Any bubbles that are there could mean a different surface tension for the probe, and so therefore it will actually suck up air when it touches the top of that bubble versus going below the surface of the actual liquid. So you always have to ensure there's no bubbles for this machine to work correctly. Okay. Now I'm taking my numbered sample and bringing it over to the actual Imulite. It is specifically asked to put it so far back away. Sample, we have to put a test tube in there, and this is patented product from Siemens. In it, it has that little bead in the very bottom there, whether you can see that well or not, but it is a coated bead, and once it's put into the machine, it will remove the sample that's just ahead of it, as I just loaded there, and put it into here, and then starting adding reagents on top of that. So it's a rather simple system, as long as we put the sample tube right behind, or the test tube right behind our sample tube, which has our serum in it. So now that we've loaded our sample and our test vial, we can start the process by hitting go. The machine will start to automatically run through the carousel, and when it comes to the specific barcode, it will read that, and then it will match it up with the data we've entered into the computer for the sample, who is Dottie, the dog. And once it gets to there, it will match up the data later on to that exact entry. The nice thing about this system is there's a representation of the entire carousel and the loading area within the screen that's right here. I'll just start right out, let's go down. So the sample has just come onto the screen. It now recognizes that there's a sample number 1. And you can see the test tube now is showing up right behind there, and so then from this point, once it gets into the carousel, we're going to track this completely around until it comes off, and we actually have data that's been read.